So here's the superior vena cava this time. This is an enlarged heart, by the way. So what is this and this? Those are the brachiocephalic veins. So we have one brachiocephalic trunk, which is an artery, but two brachiocephalic veins. Yet, for some reason, they have the model didn't show it. Did you see it? I didn't see it. Then we also have an inferior vena cava, right? So superior vena cava, inferior vena cava. It's kind of hard to see this on the cadaver because it's so low down. And then we have this opening for the coronary sinus. See? Here's the coronary sinus, bringing blood back. It's been through the heart.
Wow. Can you hold it up?
Are you showing me? Okay.
No.
Then there's some muscular comb-like ridges in the right atrium. What are those called? Do you know?
Oh, those are the
Pectinate muscles. Okay. There's a depression in the wall here in the interatrial septum, fossa ovalis, which was before birth,
Foramen.
foramen ovalum.
Ovalum.
Okay. And there's a lot happening in this right atrium. What's this little green spot supposed to represent? SA node, sinoatrial node, also known as the
Pacemaker.
Okay. And this spontaneously polarizes. It's the fastest part of the heart, sends messages to both atria here. Through what kind of junctions? How does it spread the message so fast? Gap junctions, electrical synapses. Electrical synapses, okay? And they're at the intercalated disc, okay? And the intercalated discs are just where two cells come together. You also have desmosomes holding them together so they don't come apart at the seams. You have tight junctions so you don't have leaks. Okay. So it spreads very fast, but it can't go from the atria to the ventricles because of the fibrous skeleton that acts as insulating material. So it goes very fast here, but the only way you can get to the ventricles is through a special pathway here. What's that? AV node. So there's a little delay there, so it spreads very fast here. And following that spread, then we have the atrial systole, pushing a little more blood in. Most of the blood comes in passively, 70%. Atria just pushes 30% more in. What valve are we going to go through? Not this one.
Tricuspid.
Tricuspid. Does that look like a tricuspid to you? It looks like a bicuspid to me.
Yeah.
They screwed up there. It's supposed to be a tricuspid valve, also known as the right AV valve. Now they do have the, what are these? Chordae tendineae, okay, and these are papillary muscles. When the ventricles contract, these also contract, pulling on the valves, leaflets here, so it doesn't go backwards, because the pressure gets pretty great here. Okay, now, so we're going to go from the right atrium to the right ventricle. Same thing's happening on the left side. You can either think of the heart as two upper chambers versus two lower chambers, or a right versus a left. There's different ways of looking at it. This is taking blood that's been through the system, okay? What kind of blood's coming in here? Oxygenated or deoxygenated?
Deoxygenated.
Deoxygenated blood, okay. Oh, it dropped. Okay, so now we're in the right ventricle. When the ventricles contract, they're going to push the blood. Oh, I haven't finished going through. AV valve. Then we go to the, it's called the bundle of His, or atrioventricular bundle, to the right bundle branch and left bundle branches. And then from there we go through what's called the Purkinje fibers. Last time we saw Purkinje, he was in the cerebellum. Now he's in the ventricles, okay? And that pushes the blood up when the ventricles contract, okay? From the right ventricle, what are we going to go through?
The pulmonary semilunar
Right.
valve.
Pulmonary semilunar valve, okay? So, here. So this pulmonary trunk, is it an artery or vein?
Pulmonary trunk is a vein.
Artery.
Artery. Remember, it's not what kind of blood they're carrying, it's whether it's going away from or going toward. It's going away from the heart,
Artery.
it's an artery. But it's carrying what kind of blood?
Deoxygenated.
Deoxygenated blood,
That's
okay? So that's what's a little tricky there. So in the systemic circuit, the veins carry deoxygenated blood and the arteries carry oxygenated blood. But the pulmonary circuit, everything's backwards, basically. Then we go to the right and left pulmonary arteries. What's this little doodad? Ligamentum arteriosum. It's a remnant of the
Ductus.
ductus
arteriosus.
arteriosus, which was a bypass of the lungs. This was a bypass of the lungs too. Why do we bypass the lungs in the fetus?
Because you don't need.
The lungs aren't functional. They're not even, you can't go there even if you try, because they're not inflated. Okay. So then we branch, pulmonary arteries coming in, right? Carrying deoxygenated blood, get down to capillaries, surrounding these little alveoli, air sacs. The blood's collected, gets oxygen, gets rid of carbon dioxide, goes back through the pulmonary veins. So these are 4 pulmonary veins carrying oxygenated blood going into the
Right atrium.
left.
Oh, left. Sorry.
Left.
Left.
Okay. From here we go, and by the way, what are these little extra things sticking out here? Auricles. Okay. We go from the left through what valve?
Bicuspid.
Bicuspid. It doesn't look right here. That doesn't look like a bicuspid. It's like the bicuspid over there. Should be bicuspid here, also known as mitral valve, also known as left AV valve. And there should be 2 of these, not 3. So they screwed that up too.
Oh, the number of papillary muscles is
Yeah.
different in the ventricle?
That's what I read.
Oh, that's the difference between a bicuspid and a tricuspid.
Tricuspid, yeah. This is the only valve that has only 2 parts. Everybody else has 3 parts. Now, of course, the AV valves have the chordae tendineae and the papillary muscles. The semilunar don't have those because the pressures aren't as great. You don't have to worry about them going inside out usually. Okay, so we go through the bicuspid into the left ventricle. How is the left ventricle different from the right ventricle?
It's a lot thicker.
Lot thicker wall. How about the volume? Same. And this is the septum, interventricular septum. Okay. And these muscular ridges, what are they called? Trabecular carneae, and they are larger on the left side too. Why is the left side bigger?
So it can pump all the body.
Yeah.
The body.
Much more resistance. And it's at an angle, right? This is the apex. This is called the base up here where the great vessel big enough. So now it's going to go out through the
Aortic semilunar valve.
aortic semilunar valve. And look what we have right away.
There's 2.
What are they?
Left and right coronary arteries.
Right.
It's a right coronary artery.
And actually, when the valve is open, these can't be open because it pushes against them. They're right there at the valve. So this is the ascending aorta. Then we get to the aortic arch. That's where you have your ABCs.
Yeah. And the break.
Aortic arch, brachiocephalic trunk, left common carotid, left subclavian. And the brachiocephalic trunk divides into the right subclavian and right common carotid. Common carotid is divided into
Internal.
internal and external carotids. Okay, let's look at something else here. The lining is called the what?
What?
The lining of the heart.
Is it the endocardium?
Yes. And what's most of the wall made up of?
Myocardium.
Myocardium, and the outside? Epicardium,
Pericardium.
also known as the visceral layer of the serous pericardium. Okay, so let's look at the vessels on this one. Maybe we should get the good heart out too.
The good heart?
Okay, so first branches off are the right and left coronary arteries. The right, there's going to be lots of branches, okay? Here's some major branches. So this is the marginal branch, feeding part of the wall here on the right ventricle. It comes around the back to form the posterior interventricular artery. Okay? The left coronary artery branches to form the circumflex, which feeds left atrium and ventricle. But also this vessel, which is really important. This is called the anterior interventricular artery, also called the left anterior descending, LAD, and some people also call it the widowmaker, because it feeds both ventricles and the interventricular septum. If you get a blockage here, it could be all she wrote. Okay? That's why it's called a widowmaker. And I mentioned that to a pathologist. He'd never heard that term before, but since then I've read it in other places. A pathologist told it to me. But for some people, he told me this is more important. So there's a lot of variation in the heart. Not everybody has the same vessels. and same importance. Now, the veins parallel. Coming up would be the great cardiac vein. This is a small cardiac vein, and this is the middle cardiac vein. And they empty into the coronary sinus. A sinus is a blood vessel. Do not confuse it with a sinus is in the bone. This is like a vein that has no smooth muscle, so it doesn't change shape. Okay? If I left out anything, and then, we have the interventricular sulcus, anterior sulcus, posterior sulcus. You often can't see those on the hearts because there's so much fat, usually. What's the size of a normal heart? This size? I've seen some about that big
What's
almost,
this?
about fist size supposedly.
You've seen some about that big?
I've seen some really big ones, really big ones. And that's not a good sign. That's not a good sign at all.